graph the identity function f of x is equal to x, and the standard cubic function g of x is equal to x cubed, and have the same type of symmetry. They're asking us if this is true or false. So when I go ahead and graph them, the graph of f of x is equal to x and the graph of g of x is equal to x cubed, I see that both of them are odd functions. So both functions are odd functions, and both of them are symmetry along the origin. Symmetry along the origin. So this is a true statement. So this is true. So when I graph f of x, that is an odd function. When I graph x cubed, that is an odd function, and both of them are symmetry along origin. Now, problem 2. There's so many ways of working this problem out. Use the graph of f of x is equal to x squared to obtain the graph of g of x. So let me go ahead and graph f of x is equal to x squared first. So when I take a couple of values for x, I take x as 1, 2, and 3, f of x. So then my y values are going to be 1, 4, and 9. And if I graph them here, I would have a graph something like this. And if I'm graphing g of x, which is x squared minus 2, and I'm taking my x values 1, 2, and 3, g of x would be 1 minus 2, that is negative 1, 4 minus 2, that is 2, 9 minus 2, that is 7. So my graph would be something like this, going 2 units down. So it's going to be simply going 2 units down. Use the graph of absolute value of x to obtain the graph of g of x plus 4. So when I graph this here, the absolute value, let me go ahead and plug in a couple of points for absolute value of x. So when x is 1, it's 1. When x is 2, it's 2. When x is 3, it's 3. When it's negative 1, it's 1. When it's 2, negative 2, it's 2, because it's an absolute value. So when I plot these points, I'm going to get something like this. And then absolute value of x plus 4. So if I take x's, I'm going to take a couple of values so you can see here. When I take x as 1, my y value is going to be 1 plus 4, which is 5. When I take x as 2, it's going to be 2 plus 4, which is 6. When I take x as negative 1, it's still going to be 5. When I take negative 2, it's still going to be 6. So this is technically going to be the same graph, but moving 4 units. It's going to be the same graph moving 4 units to the left. So it's going to be somewhere here. All right. I'm going to use the graph of x cubed to obtain the graph of negative of x cubed. So what happens here is the graph is going to be reflection, or it's going to be flipped along one of the axes. So we're going to find out what axis that would be. So when I draw my graph of x cubed, when I take a couple of values for x and plug them in, the graph of x cubed is going to be something like this. Right? And say this point is 1, 1. And this point is negative 1, negative 1. So when I flip this graph along y-axis, this point, negative of x cubed, so this point becomes negative 1 and 1. Right? And this point would become 1 and negative 1. So I'm simply going to flip it along y-axis, and this is what I'm going to be getting. All right? And here, for the absolute value, this value would be 0, 0. It's going to move 4 units to the left, so this value is going to be negative 4 and 0. Just a point as a reference. Use the graph of f to obtain the graph of g of x. That's equal to f of negative x. So technically what's happening in this graph is they give us the graph f of x and they're asking us to find the graph of g of x, which is obtained by changing x in f of x to negative x. See, this is the graph f of x, but we're trying to find f of negative x. And what is f of negative x? And that is equal to the graph g of x. So what we're going to do here is we're going to change the points of x values in f of x. So here, let me go ahead and do that first. So when I change the values, you see that they give us the graph of f of x and asking us to find the graph of g of x, and they're telling that you get g of x by replacing x with negative x in f of x. So I'm going to go ahead and take my f of x points here. The one point is 2, 2, so I'm going to change this point to negative 2, positive 2. This is 4, 4. I'm going to change this point to negative 4 and 0. And this is negative 2, 2. I'm going to change this to positive 2, negative 2. This is negative 4. I'm going to change it to positive 4, 0. Remember, I'm simply changing the values of the x's because that's what they said. They said I'm going to get the value g of x by simply replacing x with negative x in f of x. So when I go ahead and graph the changed points, my graph is going to look something like this. negative 2 and positive 2 would be somewhere here. Negative 2, positive 2. And negative 4 and 0. So negative 4 and 0 would be somewhere here, right? And this point here, negative 2 and 2 becomes positive 2 and negative 2. So positive 2 and negative 2 would be somewhere here. And negative 4 and 0 becomes positive 4 and 0. Let me go ahead and name this. This is 2 and negative 2. Positive 4 and 0. This is somewhere here. So when I simply go ahead and join this, my graph would be something like this. Alright. So now let's go ahead and do the next problem. They're asking us to use the graph of x cubed to obtain the graph of h of x. Okay, so and they're saying that h of x is half of x cubed. So technically they're saying that h of x is half of f of x. And what is f of x? The graph of x cubed. So what we're trying to do here is we're just gonna graph x cubed here. I'm gonna graph the function x cubed. Right? And if I take a point here, this point would be 1, 1. If I take this point here, this point would be negative 1 and negative 1. And what's happening to the graph? They're saying that the y value of h of x is half of the y value of f of x. So I'm going to simply take the y values and break them in and divide them by 2. So this is the new y value. So if the y value of f of x is 1 and 1, the y value of h of x would be 1 and half. Okay, so 1 and half is somewhere here. And remember, I'm only dividing the y values with half. And this is going to be somewhere here. So now, if I go ahead and join those two values, this graph has to pass through the origin. And something like that. So this is going to be negative 1 and half, negative half. This is going to be positive 1 and positive half. So here we're simply going to multiply the y coordinate with a half, because they said that the h of x is half of f of x. All right. All right. Let's go ahead and do the graph. The function. Use the graph f shown below to graph each function. So in this case, they gave us f of x and they're asking us to find or graph g of x. So if you need the coordinates, if you have the coordinates of g of x, we can go ahead and graph it. So let's go ahead and look what's happening here. I have a function f of x here. It's like a machine. And I have a function g of x. I'm going to draw it as a machine. Okay, they gave us the values of f of x here. The values are the x values, or I'm just picking the x values, which are 2, 0, 4, -4, and -2. So I'm going to pick the values here starting from 0, 2, 4, -2, -4. So when I put in the values into the machine of f of x, I get the outputs as for 2, I get a 2. For 4, I get a 0. For -2, I get -2. For -4, I get a 0. This is the function f of x. Now, what's happening with g of x? What did they tell us about g of x? They said the output of g of x is equal to the output of f of x when I put twice the input. That means if I put 1 in g of x, I should put 2 in f of x to get the same output. So you are inputting the values here and you are getting the output. The output of both the machines will be same when the input of f of x is twiced. So technically what you're saying is, if you want to get the same output as f of x, you have to half the input. So if it is 0, 0 over 2 is 0. If you put 2, you have to put 1 here to get the same output. Remember what they said? You have to put half of f of x to get g of x. So if you put a 4, this has to be a 2. This has to be a -1, and this has to be a -2. And if you half the inputs and put them in g of x, you're going to get the same output as f of x. Remember, the y's are not changing. Just the x values are changing. So when I go ahead and put them in here, for 0, what do I get? What is the input for 0? 0, 0. So that's 1 point. When I input a 1, I'm going to get the same output as 2. So 2 and 2. So 1 and 2. So my coordinate points are 0, 0 for g of x. These are my coordinate points for g of x. If I input a 1, the output will be 2. If I input a 2, the output will be 0. If I input a -1, the output will be -2. If I input a -2, the output will be 0. Remember, they're telling us the output stays the same if you half the input of f of x. So let me go ahead and plot those. 0, 0, 1 and 2 is going to be somewhere 1. If I say this is 1, 1 and 2, 2 and 0, and -2 and 0, -2 and 0, -1 and -2. So if I plot these points, my graph would be something like this. This is 2, 0. This is 1, 2. This is -2. No, this is -1 and -2. This is -1 and -2, and this is -2 and 0. So technically the outputs are the same, the y values are the same, but only the inputs are different. And same is the case here, g of x and f of x. They're saying that you will get the same output from the g of x when you half the inputs of f of x, right? When you put half the input, see, you're putting half x and you're putting x. When you put half x in f machine, you get the same output as when you put x in the g machine. So let's go ahead and see what for the same graph here. So this is my machine here. This is f of x, and this is my machine g of x. Remember, I have the same output, so I'm not looking at the y values. I am inputting 0, 2, 4, -2, -4, right? And this should be half of g of x, correct? That means g of x should be 0, 4, 8, -4, -8. See? F of x should be half of g of x. F of x should be half of g of x. If this is 0, if this is 0, half. If this is 4, half of 4 is 2. If this is 8, half of 8 is 4, right? Okay, so now I have the same outputs. So for 0, I'm going to have 0. For 4, I'm going to have... for 2, I had to... So 4, I'm going to have 2. For 4, what was the output for 4? 0. So for 8 also, I'm going to have the same output. For -2, the output was -2. So for -4, the output is -2. For -4, the output was 0. So for 8, the output is 0. So once I have this, I'm simply going to go ahead and plot them here. 0, 0. 4 and 2. So somewhere here. If I say this is 4 and this is 8, this is -4 and this is -8. 4 and 2 is here. 8 and 0. -4 and -2. So I'm simply going to join this. Alright, and that's so technically they're showing you that the graph has been stretched horizontally in this case, and the graph has been shrunk horizontally in the previous case. And again, they're telling you that you're going to get the same output if you put x in the machine G, and you have that and put it in the machine F. So technically you're putting twice of what you're putting in f of x. So technically I know that the transformations here are the graph moves 2 units down and it moves 3 units right because of the -3 here. It moves down because of this one, and there is a vertical stretch in the graph by half unit. So when I graph my x cube, I'm not going to take every point into consideration, but I'm going to just take the main points of the graph. This is 1, 1, and this is -1, -1, and this is 0, 0. So technically I'm moving 2 units down, so I go 1, 2. So I'm at -1 and -3 here. I'm at -1, -3, and then I go 3 units right. So from -1, 0, 1, 2, I'm at 2 and -3, and it's the graph. I stretch the graph vertically by half a unit, so I'm gonna go up 1/2 unit here. So this point here would technically be 2 and -5/2. So the graph would be, same thing would happen here. This graph would go 2 units down and then move 4 units. So this point would be, if this goes 2 units down, 1, 2, right? And then 1, 2, 3. So technically this would be 4, -3/2. So my graph would now be something like this. All right, so you're technically seeing how many units is moving up, down, left, right. There's a stretch or shrink in the graph.